All right, we're going to look at the next one. So let's check out um, homework 3.3, where we're looking at kind of putting things in standard form and playing with some other things like that. I'm going to go ahead and make this a little bit bigger. Can we see that okay? All right. So let's check out this homework. Sorry, I'm kind of playing around as I do this. So, okay. So let's look at this first one. It says that if theta is negative 7 pi over 4, find the exact values for the following. So what we're going to do is first kind of try to put this in standard form, not kind of, but put it in standard form where, you know, we put it on the XY axis. So what we want to do is get the initial side to be here, and we're going to figure out where the terminal side is. Now, negative 7 pi over 4 is a bit of a weird one. Let's go ahead and find something coterminal that's like between 0 and 2 pi, okay? So I'm going to go ahead and add a circle to this. So remember, one circle is 2 pi. So with a denominator of 4, it would look like that. Notice that's pi over 4. That means that pi over 4 is coterminal to this. And then what I'm going to do is just make a little triangle. So this is pi over 4. And we actually know a lot about pi over 4 already. We know that this length and this height are actually the same. So we know that this is square root of 2 over 2, and we know that this one is square root of 2 over 2. So now we could get the hypotenuse simply by using the Pythagorean theorem, if you want to do that. So using the Pythagorean theorem, it would be square root of 2 over 2 squared plus square root of 2 over 2 squared, which would be 2/4 plus 2/4, which is 1, which we already knew because this is the way I set it up on the unit circle. So now I can find all of the pieces. So remember, we're just going to do, just think about sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. And then we know that all of these pieces are just reciprocals of things that are kind of already there. So if we just write down the three basics, so the sine of pi over 4, sine is opposite over hypotenuse. So in other words, square root of 2 over 2. Cosine is actually the same. So the cosine of pi over 4 is also square root of 2 over 2. Let me erase all my funkiness here. And so then tangent is opposite over adjacent, so that would be root 2 over 2 divided by root 2 over 2, which would just be 1. So now that I have the basic pieces, I can find all of these. So secant is just the reciprocal of cosine. I'm recording. So can you say hi? You're on camera for everyone to see. Okay, so please go away until I'm done.
I need help.
Well, I'll have to help you when I'm done. All right, so we can fill in all the pieces now. Again, secant is going to be the reciprocal of cosine, so that will be 2 over root 2. Secant is, wait, is that secant? Oh, cosecant is 1 over sine, so reciprocal of sine. Tangent, we already figured out, is 1. Cotangent's the reciprocal of 1, which of course is 1. So now we found all of our pieces, and we can look at the next one. So notice this is the same thing. So let's just focus on, honey, you need to go. Okay, let's just focus on finding where this angle is again.
Mommy.
So let's look at 11 pi over 6. We're going to add on a complete circle, and that's going to give me pi over 6. So if you want, here's another thing you can do, is you can go ahead and convert this to degrees if you're more comfortable with degrees. So you remember, this is the conversion for that, and this is 30 degrees. So then what you can do, 30 degrees is in the first quadrant. So we can just draw our triangle in the first quadrant, and this is 30, and this is 60, Oh, wait, what did we just do? Pi over 6. Yep, that was Shh. Oh, my goodness gracious. Okay, so we can do it like this. And then we just need some pieces. And so if you recall, with a 30, 60, 90, whatever the short side is, this is always twice the short side, and this is always square root of 3 times the short side. Now, seeming so trig is ratios, we can make S whatever we want. So probably the easiest thing to pick is, I don't know, how about 1? So if this is 1, this is 2, and this is the square root of 3. Remember, it's all about ratios. So then we can say that the sine of 30 degrees, sine is just opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So here are the 3 main ones, and now all you have to do is take their reciprocals and plug them in. So it's kind of nice. And you should be able to just leave them unrationalized. Let's just see. So secant was 1 over cosine, and cosine was the opposite, so that was 1/2. So this should be able to just be 2 over 1. Cosecant is 1 over sine, so 2 over the square root of 3. Tangent, if you recall, was opposite over adjacent, so it would look like that. Cotangent is the reciprocal of that, so it would be square root of 3 over 1. And so all of these look a little weird, but I just wanted to put them in and see if it would be happy with me. Oh, it didn't like any of those, you guys. Oh, well, it was fine with the last 2. So secant is 1 over cos. Oh, you guys, I did these backwards. Oops. Secant is 1 over cosine, and cosecant is 1 over sine. Sorry about that. And it is fine with them being unrationalized, and even 2 over 1, which looks a little odd, but just so you can kind of see that reciprocal in action. All right, so question number 3 is kind of a reverse. So they're not telling me the angle at all. They're just telling me where the triangle is, and they're giving me a value of it. So it tells me it's in quadrant 4. So I'm just going to make sure, wow, I didn't center that very well for quadrant 4, did I? So it says it's in quadrant 4, so I'm just going to draw the triangle in quadrant 4. Now again, remember, the triangles are always drawn, or the angles, to the horizontal. So what I mean by that is you're never going to have a triangle like this. You see how that's drawn on the vertical? Don't draw on the vertical, always draw on the horizontal. And so this is the angle theta. I don't actually know what that is, but it does tell me the ratio for sine. And remember, sine is opposite over hypotenuse. So it says the opposite is 4 and the hypotenuse is 5. Now, by placing it in the 4th quadrant, we can actually see where the negative goes. So does the negative go with the top number or the bottom number? Well, notice how we had to go down here. So the negative is with that number. Now, with this one, you know, the hypotenuse is the 5. You wouldn't really make the hypotenuse negative, right? But let's say it had been tangent. With tangent, that's opposite and adjacent, so you won't know which one's which. So that's why if you draw it where it's supposed to be, then you can kind of see where things go. And now notice that I don't know what well, I'm about to figure out what the adjacent is. Actually, let's go ahead and do that right now. Let's use the Pythagorean theorem. So whatever this is, I'm just going to call it A for adjacent. So A squared plus -4 squared has to equal 5 squared. So notice that means that A squared is equal to 6. Whoops. Got ahead of myself there. So A squared plus 16 is equal to 25, which means that A squared must be 9, so that A is plus or minus 3. Now remember how important the plus or minus is, because you're going to pick which one to use based on where the triangle is. So again, knowing that we're in the 4th quadrant, we know we go to the right, so that means we're going to pick the +3 to go there. Okay. So now I can answer all the questions just like we did on those last ones. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Secant is the reciprocal of cosine, 1 over cosine. Cosecant is 1 over sine, so that's the reciprocal of the one they gave us. Cotangent can either be thought of as adjacent over opposite, in which case 3 over -4, or it's just the reciprocal of tangent, so then you can see the -3 over 4. Okay, so again, telling us where it is telling us, you know, which signs to pick to go where. So let's look at the next one. So this one is this is actually just like the last one, except instead of saying quadrant 1, you see what they did is they said it's between 0 and pi over 2. That tells you it's in quadrant 1. So again, just, we're not going to do this whole thing, but when you draw your triangle, just draw it in quadrant 1. And it tells me tangent. Tangent is the ratio of opposite over adjacent on acid. So opposite over adjacent. And then you can just do your Pythagorean theorem here. It'll end up being 144 plus 25, which is 169. This is actually a Pythagorean triple, so you'll know that that's 13. And then you can just figure out your ratios from there. Notice everybody's positive in the first quadrant. All right, so let's look at this next one. This just wants you to use a calculator to find these, and be careful. There are no degrees on these. So you remember the degree symbol. If it wanted degrees, or this is a mistake and I need to fix it, this would be degrees. If there's nothing written, then it's considered to be radians. Okay, so because there's no degree symbol here, we should say that it's in radians. So make sure that your calculator is in radians. And I guess I have my calculator with me. I was going to say I didn't. So I'm just going to go into mode and make sure that I'm in radians. And I'm just going to check one of these to make sure it's not a mistake in the question. So if I put sine of 0.2 radians, I'm going to get 0.19. It's 86, so I'm going to say 199. Now, just for the heck of it, I'm going to put in the degrees. So I'm going to change my mode over to degrees and do the same thing. I'm just going to say sine of 0.2. In degrees, this is 0.00349. All right, so the answer to this one should be the radians because it's marked. It's not marked with degrees. So the answer here should be 0.198. Nope, 199. So let me just check that to make sure it's not a mistake in the question. And that was correct. Okay, so this is in radians, all right? If it doesn't have the degree symbol, you assume that it is in radians, you guys. So make sure you're in radians here. That's the key there. So this one wants me to simplify to either a single trig function or just a number that has no fractions in it, a constant. And we're just going to do this using our basic identities. So looking at this one, this says secant t cotangent t. So one of the first steps for doing this is we like sines and cosines because everything's kind of based on those. So let's just change everything over to sines and cosines. So secant is 1 over cosine. Cotangent is cosine over sine. If you need to go from cotangent to tangent first, it's 1 over tangent. Then tangent would be sine over cosine, and then it would flip up. So you can do it in 2 steps if you'd like. But looking at this, notice the cosines cancel right out, or divide right out. So this is 1 over sine t, except it doesn't want fractions. So what is 1 over sine? That's the same thing as cosecant. So notice it is now just a single trig function, and that's what they wanted from us. I'm not sure if you need to put parentheses in here. If I just do cosecant t, oh, it puts the parentheses in there for you. So that's kind of nice. So this one, same thing. A kind of trick, not really trick, I guess, but hint for some of these is to get a common denominator. Okay, so notice that right now, well, let's just see what this one looks like first. That way that you can see what I'm talking about. Okay, so this is cotangent over cosecant squared minus sine squared. So let's check this one out. Cotangent over cosecant minus sine. So I'm just pulling this up so we can see the whole thing here. Actually, wait. I don't think that's recording, so never mind. Let's just go back. Okay, so let's just write on here. Okay, so we've got cotangent, which is cosine over sine. And then in my denominator, I have a cosecant, which is 1 over sine, minus sine, which is just sine over 1. So this is what I meant by getting a common denominator. You see in the denominator, we have two different fractions. Let's put those together with a common denominator. So this is going to be cosine t over sine t, all divided by, so my common denominator is going to be sine. So notice that's going to make this one sine squared over sine. So I got a common denominator here. It's a lot going on upstairs. Okay, so now what I'm going to do is flip that denominator. So I'm right over here in the yellow. I'm just going to flip that denominator up. So it would be 1 minus sine squared, which would end up on the bottom. And then the sine would be on top. See, like that. Okay, so now it looks like this. We have an identity that says that sine squared plus cosine squared is 1. So notice that means that cosine squared is 1 minus sine squared. So you see this denominator right here? That is simply cosine squared. So let's come back. I just realized I'm frozen. Ooh, I hope it's not too horrible in the frozenness. Okay. So what we're going to have is cosine t. Oh, look, those sines actually divide out as well. So we have cosine t on top, and we have cosine squared on the bottom, which is 1 over cosine, which is secant. So that was actually kind of cool. So this ends up just being secant. So let's put that in, see what it looks like. Yay. All right, on question number 8, I would do the same thing we just did. So on top, you have 1 plus sine. On the bottom, you'll have 1 plus 1 over sine. And now another thing you can do there, so actually let me show you this just real quick. You have 1 plus sine over 1 plus 1 over sine. So another kind of trick here, we can multiply by sine over sine. And notice what that does. You do have to distribute that, so be careful. I'm just going to do this in yellow over here. So what you get when you do that is 1 plus sine times sine divided by, now notice when you distribute that, you're going to get a sine t plus 1. You see how it got rid of the fraction. So now it looks like this. And if I just stick parentheses on this, it might make it more obvious. But check it out. 1 plus sine t, 1 plus sine t. So those divide out, and you actually just get a sine. So that was kind of cool. So the whole answer there will just be sine. The top of this one is 1. You see that? Sine squared plus cosine squared is 1. Number 10 is find the area of a triangle with the given information and round your answer to the nearest 10. So we actually have a formula for finding the area of a triangle. And let me just pull that up for you real quick. This was at the end of 3.3. Where is it? Math 114, 3.3. So at the end here, we had a formula for area. Oh, that was all of our pieces. All right, so this comes from area being equal to 1/2 base times height, right? Which is our normal formula for an area. Now, if you set that up in a triangle, that was a bad one to pick. If you set this up in a triangle, and this is your theta. Notice then that the base, actually, I guess it's the other one is the theta. We're going to make this into sine. Well, goodness gracious. Okay, so you need to kind of see the whole thing, I guess. That was really bad. So what you're technically doing is you've got this theta here. So notice that the sine of theta would be opposite. This is the height over the hypotenuse. Let's call him for now, because he's h for height, let's just call him A. And then we'll have our base be the B, or actually maybe the B is just over there. So anyway, the formula, so when you end up plugging in kind of this base times height, to find the height, notice that the sine of theta is equal to the opposite over the hypotenuse. So this is actually height over A. So if you multiply that by AB, the A's cancel out, divide out, and you're left with base times height. You see, this is base and height. So anyway, it's just substituting these things in. So this is a nice formula, and it works very nicely. So 1/2 AB sine theta. So this is the area of a triangle with sides of length A and B, and with the included angle, keep that in mind, the included angle has to be the theta. So let's look back at this one that we were doing. All right, so let's just draw our triangle here. It says find the area of the triangle. This is not necessarily a right triangle. It just says, well, this isn't drawn very much to scale, but let's just say that's 19 and that's 25. So here's our A and here's our B, and then C. Hold on, I'm on the last one, honey. So let's just look at C, which would be 39 degrees. So you remember when you label, your angle is always across from, so this is angle A, and notice he's across from A. So this would be angle B. He's across from little b, so it would look like this. So anyway, we can just plug this into the formula now. So, oops. So the area, which they use that big fancy A, is equal to 1/2 A times B times the sine of 39 degrees. And see, by included angle, we mean the angle that's between the two sides that are given. So now this is in degrees, right? Because the 39 was in degrees. So just make sure your calculator is in degrees, and I can plug this in and say 0.5 times 25 times 19 times the sine of 39. And so I've got that in my calculator. Let's just put this in. I'm also just curious, because I'm curious about lots of things, what would happen if I just put in 1/2 A times, oh, there's not like a times, oh, parentheses, 1/2 A times B. It's going to get mad at me, I bet. I was just curious if I could do it this way. Sine of 39. So this is where the formula is coming in. Nah, it wouldn't let me. Okay, I was just curious. So actually in the calculator, this is 149 point. Oh, it does say round, doesn't it? To the nearest tenth. So that would be a 5, actually. I just noticed information is spelled wrong. So anyway, there is your 3.3 homework in a nutshell, and that's it.